everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve the given differential equation. So let's get going. Problem: solve x minus y minus 2 into dx plus x minus 2y minus 3 into dy equals to 0. Solution: given differential equation. X minus y minus 2 into dx plus x minus 2y minus 3 into dy equals to 0, which is in a1x plus b1y plus c1 into dx plus a2x plus b2y plus c2 into dy equals to 0 form, right? Which is in non-homogeneous differential equation form. Fine. Now you can write this equation as, consider the given equation as equation 1. X minus 2y minus 3 into dy equals to minus of x minus y minus 2 into dx. Then dy by dx equals to minus of x minus y minus 2 by x minus 2y minus 3. We'll simply write in dy by dx equals to some function of xy form. Okay, fine. This equals to minus x minus into minus plus y minus into minus plus 2 by x minus 2y minus 3. So we have dy by dx equals to minus x plus y plus 2y x minus 2y minus 3. Let's consider it as equation number 2. Fine. Which is in dy by dx equals to a1x plus b1y plus c1 by a2x plus b2y plus c2 form. That is the given this equation otherwise is in non-homogeneous differential equation form. Okay. Fine. Now by comparing these two, we'll get the values of a1, b1, c1, a2, b2, c2. Right. Now coming to the numerator, quotient of x is your a1. So a1 equals to minus 1. And quotient of y is your b1. b1 equals to 1. And c1 is 2. Coming to the denominator, quotient of x is your a2, that is 1. And quotient of y is your b2, minus 2. And c2 is minus 3. Okay. Or simply, you can just consider it as dy by dx equals to f of xy form. Right, it is also is in this form. So here f of xy will be this function. Minus x plus y plus 2y x minus 2y minus 3. Right. If f of kx ky equals to f of xy, then we can say that this function is a homogeneous function. Then the differential equation involving homogeneous function will be called as homogeneous differential equation. If this does not happen, then we call this equation as non-homogeneous differential equation, since the function is not homogeneous. Okay, if you want, you can check by replacing x by kx and y by ky equals to minus kx plus ky plus 2 by kx minus 2 ky minus 3. See here you are having constants, right? So there is k in first two terms of numerator and denominator, so there is not possible. There is no possibility of cancelling k from the numerator and the denominator. So this is not equals to f of xy. Okay. So here 2 is a non-homogeneous differential equation. Now, find a1 b2 minus a2 b1 is equals to a1 minus 1 into b2 minus 2 minus a2 1 into b1 1 is equals to minus 1 into minus 2 is 2 minus 1 which is equals to 1 which is not equals to 0. Therefore, a1 b2 minus a2 b1 is not equals to 0, right? Since a1 b2 minus a2 b1 is not equals to 0, so we'll solve equation 2 by putting, since a1 b2 minus a2 b1 is not equals to 0, so we'll solve 2 by putting x equals to capital X plus h and y equals to capital Y plus k. Okay. So you're having x equals to capital X plus h, right? If you differentiate on both sides with respect to capital X, then you'll get dx by d capital X equals to derivative of capital X with respect to x with respect to capital X is 1 plus derivative of h, that is constant, with respect to capital X is 0. From this we'll get dx by d capital X equals to 1. So d small x equals to d capital X, right? Then dx equals to d capital X, and we have small y equals to capital Y plus k. Now differentiate on both sides with respect to capital Y. Then dy by d capital Y equals to d capital Y by d capital Y plus derivative of constant with respect to y. Then you'll get d small y by d capital Y equals to derivative of y. Derivative of capital Y with respect to capital Y is 1 plus derivative of a constant with respect to y is 0. Then we'll get dy differential d small y by d capital Y equals to 1. From this we'll get d small y equals to 1 into d capital Y is d capital Y, right? And dy equals to d capital Y. Also, dy by dx becomes d capital Y by d capital X. Okay. Now we can replace dy by dx by d capital Y by d capital X and x by capital X plus h and y by capital Y plus k. Okay. 2 becomes dy by dx equals to minus of capital X plus H plus for small y equals to capital Y plus K plus 2 by X capital X plus H minus 2 times capital Y plus K minus 3. This becomes dy by dx equals to minus x minus h plus y plus k plus 2 by x plus h minus 2y minus 2k minus 3. Then dy by dx equals to, firstly we'll write x and y term minus x plus y plus the remaining 3 terms minus h plus k plus 2 by x y term plus remaining terms h minus 2k minus 3. Consider as equation number 3, okay, which is in dy by dx equals to a1x plus b1y plus a1h plus b1k plus c1 by a2x plus b2y plus a2h plus b2k plus c2 form, right? See here we are having quotient of x and h is a1. What is a1? Minus 1. So see you are having minus 1 as a quotient of x and h in the numerator. Now coming to y and k. Quotient of y and k is b1. b1 is 1. Okay. Quotient of y and k is 1. b1. Now coming to x and h in the denominator, you're having quotient of x and h is a2. a2 is 1. X and h quotients are 1. And here you're having quotient of y and k is b2. b2 is minus 2. Right, the quotient of y and k is minus 2. And you're having c2 equals to minus 3. c1 equals to 2. Fine. Now, what we have to do is, we have to choose h and k such that these two polynomials should become 0, such that minus h plus k plus 2 equals to 0 and h minus 2k minus 3 equals to 0. So how you will get h and k values? Simply by solving these two equations. Okay, so here we are going to use cross multiplication method to solve these two equations. Okay, h k 1 or so this is a cross multiplication method. Take h, k and 1. Firstly write the equations of k, 1 minus 2, constants 2 minus 3, equations of h minus 1, 1, again equations of k, 1 minus 2. See, ends with b1 b2, also starts with b1 b2. Okay, Now this becomes h by 1 into minus 3 is minus 3 minus of minus 2 into 2. Minus 2 into 2 is minus 4 equals to k by 2 into 1, 2 minus of minus 3 into minus 1 is 3 equals to 1 by minus 1 into minus 2, 2 minus of 1 into 1, 1. Then you'll get h by minus 3 minus into minus plus 4 equals to k by 2 minus 3 equals to 1 by 2 minus 1. Then h by 4 minus 3 is 1 equals to k by 2 minus 3 is minus 1 equals to 1 by 2 minus 1 is 1. Now equate first one and last one, you'll get better. Can write 1 by 1 as 1. Now equate first and last one. You'll get h by 1 equals to 1. From this h equals to 1. Now equate these two. K by 1 equals to 1. Sorry, k by minus 1 equals to 1. From this we'll get k equals to minus 1 into 1 is minus 1. So we got the values of h and k. H equals to 1 and k equals to minus 1. Now we have to check whether hk satisfies these two equations or not. Okay. This is the first equation. Consider LHS part. Now put the values of h and k. Minus 1. Value of k is minus 1 plus 2, which is equals to minus 1 plus into minus minus 1 plus 2 equals to minus 1 is minus 2 plus 2 equals to 0. So h and k satisfies the first equation. Likewise, we have to check for the second equation. H minus 2k plus 3 equals to 0 is our second equation. Consider LHS part. H minus 2k minus 3 equals to, now substitute the values of h and k. 1 minus 2 into minus 1 plus 3 equals to 1. Minus into minus plus, 2 ones are 2, minus 3 equals to 1 plus 2, 3 minus 3 is 0. So second equation is also satisfied. So we got the values of h and k that satisfies these two equations, right? From this we can say that hk values are correct, right? Therefore h equals to 1 and k equals to minus 1 such that these two polynomials become 0. Minus h plus k plus 2 equals to 0 and h minus 2k minus 3 equals to 0, right? Then equation 3 becomes dy by dx equals to minus x plus y plus this equals to 0, right? And this also equals to 0. Plus 0 by x minus 2y plus 0. Then dy by dx equals to minus x plus y by x minus 2y. Consider it as equation number 4. Now we'll check whether this equation is homogeneous or not. So this is of some dy by dx equals to function of xy form, right? If, okay, let f of xy, that is function of xy, is equals to minus x plus y by x minus 2y. If f of kx ky equals to f of xy, that is function of xy, then we call this function as homogeneous function. Then the differential equation involving homogeneous function will be called as homogeneous differential equation. Now let's find function of kx ky equals to, simply replace x by kx and y by ky in function of xy, then you'll get minus kx plus ky by kx minus 2ky. This is equals to, take k common from the numerator and the denominator, you'll get k times minus x plus y by k times x minus 2y. Here k gets cancelled and this is equals to minus x plus y by x minus 2y, which is a function of xy, right? Or since f of xy equals to minus x plus y by x minus 2y, right? So it's clear that function of kx ky equals to function of xy. From this we can say that this function is a homogeneous function, and the differential equation involving homogeneous function is called homogeneous differential equation. So here our equation 4 is homogeneous differential equation. Right. So we have reduced the given non-homogeneous differential equation to homogeneous differential equation. Now we'll solve this equation 4 by using homogeneous method of solving. Okay, simply we'll put y equals to vx to solve the given equation. Oh, sorry, to solve this equation 4. Okay, put y equals to vx. Now differentiate on both sides with respect to capital X. Then dy by dx equals to, here we'll use uv whole dash formula, which is equals to u dash v plus v dash u, derivative of v with respect to x into x plus derivative of x with respect to x into v. Then we'll get dy by dx equals to x into dv by dx plus derivative of x with respect to x is 1 into v So from this you'll get dy by dx equals to v into 1 is v plus x into dv by dx. Okay. Now replace dy by dx by this and y by vx. Then 4 becomes v plus x into dv by dx equals to minus x plus vx, okay, by x minus 2 vx. And we'll get v plus x into dv by dx equals to Take x common from the numerator, you'll get x times minus 1 plus v by. Also take x common from the denominator, you'll get x times 1 minus 2v. Here x gets cancelled. Then v plus x into dv by dx equals to minus 1 plus v by 1 minus 2v. Then this becomes, simply take this v2 RHS, you'll get x into dv by dx equals to minus 1 plus v by 1 minus 2v minus v. Which is equals to minus 1 plus v minus v times 1 minus 2v by 1 minus 2v. Simply we'll take LCM. Okay. Minus 1 plus v minus v into 1 is minus v, minus into minus plus v into 2v is 2v square by 1 minus 2v. Here plus v minus v gets cancelled and this is equals to minus 1 plus 2v square by 1 minus 2v. Now take minus common from the numerator and denominator. You'll get minus of 1 minus 2v square. Minus into 1 minus 1. Minus into minus plus 2v square by minus of 2v minus 1. Minus 2v minus into minus plus 1. Okay. Now minus gets cancelled. You'll get 1 minus 2v square by 2v minus 1. Now, see in LHS, you're having x into dv by dx, right? Since you're having dv in the numerator of LHS part, so we'll write functions of v and dv in LHS and we'll take functions of x. We'll write all the functions of x and dx on RHS. Okay, we're having x into dv by dx equals to 1 minus 2v square by 2v minus 1. Since you're having dv in the numerator of LHS, so we'll take all the functions of x to LHS. Then the above equation becomes 2v minus 1 by 1 minus 2v square into dv equals to 1 by x into dx. Fine. Consider 1 minus 2v square as one term and 2v minus 1 as two terms. Okay, 2v as one term and minus 1 as other term. And split this into two terms. And also this fraction is a proper fraction. Okay, degree of the polynomial in the numerator is 1 and the degree of the polynomial in the denominator is 2. Then you get 2v by 1 minus 2v square into dv minus 1 by 1 minus 2v square into dv equals to 1 by x into dx. Now we can perform integration. Okay. Firstly, evaluate the first integral. Integral 2v by 1 minus 2v square into dv. Let f of v equals to 1 minus 2v square. Then f dash of v will be 0 minus 2 2s are 4v. Derivative of v square is 2v, right? You can just write this as minus 2 into derivative of v square is 2v, which is equals to minus 4v, right? Since we know that integral f dash of v by f of v into dv equals to log mod f of v plus integral constant c. In order to apply this formula here, we need a dash of x in the numerator. For that, we need minus 2 here, right? So, what we'll do is, we'll simply multiply and divide with minus 2, okay? Which is equals to, take this minus 2 inside the integral, you'll get, okay, 1 by minus 2 into integral 4v minus 2 into 2 is minus 4v by 1 minus 2v square into dv, right? This equals to, you can write 1 by minus 2 as minus 1 by 2 into integral minus 4v by 1 minus 2v square into dv. Since integral f dash of v by f of v is equals to log mod f of v, then this becomes log mod 1 minus 2v square. We don't write plus c here, okay? We'll write finally after evaluating these two integrals or these three integrals. Therefore, integral 2v by 1 minus 2v square into dv equals to minus 1 by 2 log mod 1 minus 2v square. Fine. Now let's evaluate the second integral. Integral 1 by 1 minus 2v square into d is equals to integral. Now take 2 common from the denominator. You'll get 1 by 2 times. Since you don't have any 2 in the first term, right? So, simply write this as 2 by 2 minus 2v square into dv. Then it will be easy to take 2 common from the 2 terms in the denominator. This is equals to integral 1 by, now take 2 common from the denominator, you will get 2 times 1 by 2 minus v square into dv. Now take 1 by 2 outside the integral, you will get 1 by 2 integral 1 by 1 by 2 minus v square into dv. Okay. Here you're having v square, right? We can also write the first term in terms of square. You're having 1 by 2, right? So, you can write 1 by 2 as 1 by square root of 2 whole square, okay? Or simply 1 by 2 as 1 by square root of 2 whole square. Since square root of 2 whole square equals to, we know that square root of a can be written as a power 1 by 2. Then you can write square root of 2 as 2 power 1 by 2 whole power 2. And we know that a power m whole power n equals to a power m into n. Then this becomes 2 power 1 by 2 into 2. Here 2 gets cancelled, we'll get 2, right? So, 2 is nothing but, or square root of 2 whole square is nothing but 2. So, we'll replace 2 by square root of 2 whole square. And you can write this as 1 by square root of 2 whole square. Okay. Then this becomes 1 by 2 into integral 1 by, replace 1 by 2 by 1 by square root of 2 whole square. minus v square into dv. Since we know that integral 1 by a square minus x square into dx equals to 1 by 2a into log mod a plus xy, a minus x plus integral constant. Okay, then by comparing these two, for a equals to 1 by root 2 and for for x equals to v, this integral becomes 1 by 2 into 1 by 2a, 1 by 2a, for a equals to 1 by square root of 2 into log mod a plus x, 1 by root 2 plus for x equals to v by a minus x, for a equals to 1 by root 2 and for x equals to v. Okay, we'll not write constant here, we'll write later. We know that 2 equals to 2 power 1, right? You can write 1 as half plus half. You can again split this as 2 power half into 2 power half. We know that a power 1 by 2 equals to square root of a, then 2 power 1 by 2 can be written as square root of 2. So you can write 2 as square root of 2 into square root of 2. Then this 1 by 2 into 1 by square root of 2 becomes, replace 2 by square root of 2 into square root of 2 into 1 by square root of 2, so that 1 square root of 2 gets cancelled and you'll get 1 by square root of 2, right, is equals to 1 by 2 times 1 by 2 times 1 by square root of 2 is 1 by square root of 2. And see here you're having 1 by square root of 2 plus v by 1 by square root of 2 minus v. Take the LCM in the numerator, you'll get 1 plus v root 2 by root 2 by, here also take the LCM, you'll get 1 minus v root 2 by root 2. So you can write this as 1 plus v into square root of 2 by root 2 into root 2 by 1 minus v root 2. So here square root of 2 gets cancelled and you'll get 1 plus v root 2 by 1 minus v root 2. So you can replace this, that is 1 plus square root of 2 plus v by 1 by square root of 2 plus v by 1 by square root of 2 minus v by 1 plus v root 2 by 1 minus v root 2. You'll get log mod 1 plus v root 2 by 1 minus v root 2. This is a second integral, right? Therefore, integral 1 by 1 minus 2v square into dv equals to this one. Now, coming to the solution. You can just write this as integral 1 by x dx equals to integral 2v by 1 minus 2v square dv minus integral 1 by 1 minus 2v square into dv. Integral 1 by x dx is log mod x equals to integral 2v by 1 minus 2v square dv is minus 1 by 2 log mod 1 minus 2v square minus integral 1 by 1 minus 2v square into dv is 1 by 2 times 1 by square root of 2 log mod 1 plus v root 2 by 1 minus v root 2 plus integral constant log c. Since c being constant, we can write log c instead of c. Okay? Log c is also a constant. So you're having all the three terms in log, so we'll write integral constant as log c. Then log x equals to minus 1 by 2 log 1 minus 2v square minus 1 by 2 times 1 by square root of 2 into log 1 plus v root 2 by 1 minus v root 2 plus log c. Right. Now take 1 by 2 common from all the terms in RHS. 1 by 2 times minus log 1 minus 2v square minus 1 by square root of 2 log 1 plus v root 2 by 1 minus v root 2 plus, see we don't have 1 by 2, right? So we'll include 2 log c. 1 by 2, since 1 by 2 into 2 is 2 by 2 equals to 1. Okay. Now in the next step, take this 2 to RHS, becomes 2 log x equals to minus log 1 minus 2v square minus 1 by square root of 2 log 1 plus v root 2 by 1 minus v root 2 plus, we know that m log n can be written as log n power m, then we can write 2 log c as log c square. Okay? Since m log n equals to log n power m, then you can write 2 log x as log x square. Now take this to LHS, it becomes plus log 1 minus 2v square equals to minus 1 by square root of 2 into log 1 plus v root 2 by 1 minus v root 2 plus, since c is constant, you can write c square as c. Okay? Log c. Fine. This equals to, you can write this as, since m log n equals to log n power m, then you can write this as log 1 plus v root 2 by 1 minus v root 2 power minus 1 by square root of 2 plus log c as it is. Since we know that log a plus log b equals to log ab, then this becomes log x square into 1 minus 2v square equals to log c into 1 plus v root 2 by 1 minus v root 2 power minus 1 by square root 2. Okay, we know that if log a equals to log b, then a equals to b. Then this becomes x square into 1 minus 2v square equals to c times 1 plus v root 2 by 1 minus v root 2 or minus 1 by square root 2. Now consider this one. 1 plus v root 2 by 1 minus v root 2 power minus 1 by square root of 2. Since we know that a power m whole power n equals to a power m into n, which is equals to a power mn, right? Now, you can write this minus 1 by square root of 2 as minus 1 into 1 by square root of 2, right? M into n. Now, again you can write a power m into n as a power m whole power n. You can just write this as a power m whole power 1 by square root of 2. Okay. A power minus 1 is nothing but reciprocal of 1 plus, that is a. Okay, if you consider this as a, you can just write this as 1 by 1 plus v root 2 by 1 minus v root 2 power 1 by square root of 2. Okay, you can write this as 1 into, we know that a by c by b by c can be written as a by c into c by b. Likewise, we'll write this 1 as 1 by 1. Then you can write this as 1 by 1 into 1 minus v root 2 by 1 plus v root 2 power 1 by square root of 2. We'll just write the whole number as a fraction. 1 as 1 by 1 is equals to 1 minus v square root of 2 by 1 plus v square root of 2 power 1 by square root of 2. Since 1 plus v root 2 by 1 minus v root 2 power minus 1 by root 2 is equals to this one. So, coming to the solution, this becomes x square into 1 minus 2v square equals to c into, replace this by this one, 1 minus v root 2 by 1 plus v root 2 per 1 by square root of 2. Since we have y equals to vx. From this, we can write vx equals to y. From this, we'll get v equals to y by x. Now replace v by y by x, and this becomes x square into 1 minus 2 v square, that is y by x whole square, equals to c into 1 minus v y by x into root 2 by 1 plus y by x into root 2 for 1 by root 2. Then this becomes x square into 1 minus 2 y square by x square equals to c into 1 minus y root 2 by x by 1 plus y root 2 by x for 1 by root 2. Now take the LCM. Then x square into 1 is x square minus 2y square by x square equals to c times x into 1 x minus y root 2 by x into 1 x plus y root 2 by x for 1 by root 2. Here x square gets cancelled, then x square minus 2y square equals to c times, you can just write this as x minus y root 2 by x into x by x plus y root 2 for 1 by root 2. Then x square minus 2y square equals to c times, here x gets cancelled and you'll get c times x minus y root 2 by x plus y root 2 for 1 by root 2. Now we'll replace x and y. Since we have small x equals to capital X plus h and small y equals to capital Y plus k, put h equals to 1 and k equals to minus 1, you'll get x equals to capital X plus 1. From this you'll get x minus 1 equals to h, that is capital X equals to x minus 1. Coming to y equals to capital Y minus 1. Take this minus 1 to LHS, you'll get small y plus 1 equals to capital Y. Capital Y equals to y plus 1. Now replace x by x minus 1 and y by y plus 1. Then you'll get x minus 1 whole square minus 2 times y plus 1 whole square equals to c times x minus 1 minus of y plus 1 into square root of 2y, x minus 1 plus y plus 1 into square root of 2 for 1 by 2. You can simplify this. This is of a minus b whole square form and this is of a plus b whole square form. Just expand it. X square plus x square plus 1 square 1 minus 2x minus 2 times y square plus 1 plus 2y equals to c times x minus 1 minus y root 2. Minus 1 into root 2 is minus root 2 by x minus 1 plus y into root 2 y root 2 plus 1 into root 2 is root 2 for 1 by root 2. Then x square plus 1 minus 2x minus 2y square minus 2 into 1 minus 2 plus minus 2 into 2y is minus 4y equals to c times x minus y square root of 2 minus square root of 2 minus 1 by x plus y root 2 plus root 2 minus 1 power 1 by root 2. Then x square minus 2y square minus 2x minus 4y plus 1 minus 2 is minus 1 equals to c times x minus y root 2 minus root 2 minus 1 by x plus y root 2 plus root 2 minus 1 or 1 by root 2. This completes the problem, which is the required general solution. So we have seen a problem from non-homogeneous equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.